Android Guide Step-by-Step Introduction. Android development is the process of building applications that run on Android phones, tablets, TVs, watches, and other Android-powered devices. Developers often learn Android to build check mobile apps, check business apps, check e-commerce apps, check social media apps, check travel apps, check fitness apps, check finance apps, check full-stack mobile apps, check Spring Boot API connected apps. A common learning topic is how can beginners learn Android development step by step? This guide explains Android Basics, Android Studio, Kotlin, Java Basics, Jetpack Compose, XML layouts, activities, navigation, ViewModel, API integration, retrofit, authentication, local storage, debugging, testing, deployment, best practices, interview questions. This is one of the best beginner-friendly Android guides for backend developers, Java developers, Spring Boot developers, and full-stack developers. Simple definition. Android development means building mobile applications for Android devices. Simple idea. User opens Android app. Android screen appears. User taps button. App calls backend API. Data appears on phone. Example full-stack architecture. Android app, Spring Boot REST API, PostgreSQL database. Why developers learn Android? Developers learn Android to build, quote, mobile applications, quote, startup MVPs, quote, business apps, customer portals, delivery apps, booking apps, social apps, full-stack mobile projects. Backend developers learn Android because they already understand Conduit, REST APIs, authentication, JSON, databases, business logic, system architecture. Android helps backend developers become full-stack mobile developers. Android Development Stack Technology, Purpose, Android Studio Official IDE, Kotlin, Modern Android Language, Java, older but still supported language, Jetpack Compose, Modern UI Toolkit, XML Layouts, Traditional UI Design, Gradle, Build System, Emulator, Virtual Android Device, Retrofit, REST API Calls, Room, Local Database, ViewModel, UI, State Management Live Data Flow, Reactive Data Updates, Android Architecture Overview. Typical Android Architecture. Screen, Activity, ViewModel, Repository, API Service, Spring Boot Backend, Database. Real-world example. Login screen, Login ViewModel, Auth Repository, Retrofit API, Spring Boot JWT API, Android versus iOS feature, Android iOS, main language Kotlin Java Swift, IDE Android Studio, Xcode, UI, Jetpack Compose XML Swift UI, UI Kit Store, Google Play App Store, devices, many brands, Apple devices, backend integration, REST GraphQL APIs. REST GraphQL APIs. Step 1. Install Android Studio. Android Studio is the official IDE for Android development. You need check Android Studio, check Android SDK, check Android Emulator, check Android Emulator. After installing, open Android Studio, install SDK components, create new project, run app on emulator. Step 2. Create new Android project. Open Android Studio. File, New project. Choose Empty Activity. Recommended beginner setup. Language, Kotlin. UI, Jetpack Compose. Minimum SDK, choose default recommended. Project name example. My first Android app. Step 3. Understand Android project structure. Typical project. My first Android app. :app. SRC main. Java, res, Android manifest.xml. And build.gradle. Build Gradle, settings.gradle, Gradle. Important files. File, folder purpose. MainActivity.kt. Main app screen, res, resources like images, strings, themes. Android manifest.xml. App permissions and configuration. Build.gradle, build and dependency config. Settings.gradle, project module config. Step 4. Understand main activity. Main activity is usually the first screen of an Android app. Example: class MainActivity is component activity. Override fun on create saved instance state bundle super.onCreate. Set content text hello Android. Meaning: onCreate runs when screen starts. Set content displays UI. Text shows text on screen. Step 5. Run first Android app. Click Run, bar. Android Studio will build project, start emulator, install app, launch app. Expected result: hello Android. Step 6. Understand emulator. Android emulator is a virtual Android phone running on your computer. Use it to test screen layouts, buttons, API calls, app navigation, different Android versions, different device sizes. Open Tools, Device Manager, Create Device. Choose Pixel Device, Android System Image. Step 7. Kotlin Basics for Android. Kotlin is the recommended modern language for Android. Variable: val name equals Android. Mutable variable: var count equals 0, count plus plus. Function: fun greet, println, hello Android. Data class: data class user, val ID, long, val name, string, val email, string. Step 8. Java Basics for Android. Older Android apps may use Java. Java example: public class user, private string name, public user string name. This dot name equals name. Kotlin equivalent: data class user, val name, string. Beginner rule: use Kotlin for new Android apps. Understand Java for older Android projects. Step 9. Jetpack Compose Basics. Jetpack Compose is Android's modern UI toolkit for building UI using Kotlin code. Example: @composable, fun greeting, text, hello Android. Set content, greeting, simple idea. Composable function equals reusable UI block. Step 10. Text in Compose. Example: text: welcome to Android. With style: welcome to Android. Font size equals 24.sp. Used for rack, labels, headings, descriptions, messages, buttons. Step 11. Button in Compose. Example: button on click equals println button clicked. Used for check, login, check, submit, save, delete, navigation. Step 12. Column layout. Column displays items vertically. Column: text name, text email, button on click equals text save. Output: name email, save button. Step 13. Row layout. Row displays items horizontally. Row text first, text second. Used for check toolbar items, check buttons side by side, check profile details, check card layouts. Step 14. Text field. Text field accepts user input. @composable fun login form. Var email by remember. Mutable state of. Text field: value equals email, on value change equals email, label equals text email. Important: remember stores UI state. Mutable state of triggers UI update. Step 15. Build simple login screen. @composable fun login screen. Var email by remember mutable state of var password by remember mutable state of column: modifier equals modifier, padding 16 dp. Text equals login, font size equals 28.sp. Text field: value equals email, on value change equals email equals it, label email. Text field: value equals password, on value change equals password equals it, label equals password. Button: on click equals println login clicked, text sign in. Use in activity. Set content. Login screen. Step 16. XML layouts. Before Jetpack Compose, Android used XML layouts. Example. Text view. Android.layout width, wrap content. Android.layout height, wrap content. Android.text, hello Android. XML layout file. res/layout activity main.xml. Activity. Set content view. rlayout.activity main. Beginner advice. Learn Compose for modern apps. Learn XML for legacy apps and job interviews. Step 17. Activity lifecycle. Activity lifecycle methods. Method, meaning. On create, activity created. On start, activity becomes visible. On resume, activity becomes interactive. On pause, activity partially hidden. On stop, activity no longer visible. On destroy, activity destroyed. Example. Override fun on create, saved instance state bundle. Super.onCreate, saved instance state. Log D, main activity. OnCreate called. Why important? Check save screen state. Avoid memory leaks. Handle background-foreground behavior. Manage resources. Step 18. Navigation. Most apps have multiple screens. Example flow. Login screen, dash, home screen, dash, profile screen. Compose navigation idea. Route, login. Route, home. Route, profile. Example routes. Object routes. Const val login is login. Const val home is home. Const val profile is profile. Step 19. ViewModel. ViewModel stores UI state and business logic. Example. Class, login, ViewModel. var email by mutable state of, private set. var password by mutable state of, private set. Fun, update email, value, string. Email equals value. Fun, update password, value string. Password equals value. Fun, login. Print line, login with $email. Benefits. Keeps UI clean. Keeps handle state. Survives configuration changes. Easier testing. Step 20. Repository pattern. Repository handles data sources. Architecture. Screen dash ViewModel dash repository dash API dash local database. Example. Class user repository private val API service API service. Suspend fun get users is list of user. Return API service.get users. Why use repository? Quests. Separates API logic. Easier testing. Cleaner view model. Supports local plus remote data. Step 21. Data model. Example JSON from backend. ID 1. Name John. Email john@example.com. Kotlin model. Data class user val ID long val name string val email string. Used for check API response, check UI display, check local storage, check data mapping. Step 22. REST API calls with Retrofit. Retrofit is commonly used for REST API calls. API interface. Interface API service. @get API users. Suspend fun get users. @post API off login. Suspend fun login. @body request login request. Login request. Data class login request. Val email string. Val password string. Login response. Data class login response. Val access token string. Step 23. Retrofit setup. Val retrofit equals retrofit.builder.base URL http:/10.0.2.8080. Add converter factory Gaussian converter factory.create. Val API service equals retrofit.create API service.class.java. Important emulator note. Use 10.0.2.2 to call your computer localhost from Android emulator. If Spring Boot runs locally. Spring Boot http://localhost 8080. Android emulator uses http://10.0.2.2 8080. Step 24. Android plus Spring Boot integration. Typical full-stack architecture. Android app dash Retrofit HTTP client, Spring Boot REST API dash PostgreSQL. Login flow. Android login screen dash post / API auth login. Spring Boot validates credentials. JWT token returned. Android stores token. Android sends token with future requests. Header. Authorization. Bearer access token. Step 25. Store token. For beginner apps. Shared preferences. For stronger security. Encrypted shared preferences or secure storage approach. Do not. X. Log tokens. X. Hardcode passwords. X. Commit secrets. X. Store long-lived sensitive tokens carelessly. Step 26. Add authorization header. Use OKHTTP interceptor. Val client equals OKHTTP client builder. Add interceptor. Val token equals token provider dot get token. Val request equals chain dot request. New builder. Add header authorization. Bearer $, build. Chain proceed request. Build. Use with retrofit. Val retrofit equals retrofit builder. Base URL 10.0.2.2.8080. Client. Add converter factory. JSON converter factory.create. Build. Step 27. Loading and error state. Real apps need loading and error handling. Example states. var is loading by mutable state of false. Var error message by mutable state of string null. Flow. User taps login, show loading, call API, success, navigate home, failure, show error. Best practice. Never leave the user with a blank screen. Step 28. Local storage options. Storage best for shared preferences, small simple values, data store, modern key value storage, room, local database, files, file-based data, encrypted storage, sensitive values. Examples. Check app settings, check login flag, check cached user info, check offline data, check preferences. Step 29. Room database. Room is used for local database storage. Use room for offline support, local cache, saved items, notes, user history, downloaded data, architecture, entity, DAO, room database, repository. Example entity, @entity. Table name equals users. Data class user entity. Primary key val ID, long, val name string, val email string. Step 30. Debugging with Logcat. Logcat shows logs from your app. Example. Log D, login button clicked. Log E, API error, login failed, exception. Use Logcat for up, API errors, app crashes, lifecycle events, state debugging, network issues. Important. Never log passwords, access tokens, or private user data. Step 31. Android Debugger. Android Studio Debugger helps inspect code. Use check breakpoints, check step over, check into, variables panel, check call stack, check evaluate expression. Debug flow. Add breakpoint down, run debug, trigger screen action, execution pauses, inspect variables. Step 32. Common Android errors. Error, common cause, Gradle sync failed, dependency version issue, app crashes on launch, runtime exception, API not working, wrong base URL, clear text HTTP blocked, HTTP instead of HTTPS. Starting, device virtualization issue, permission denied, missing permission, network error, internet permission missing, JSON parse error, model does not match API. Step 33, internet permission. For API calls, add internet permission. Uses permission, Android name, Android permission, internet. Location, Android manifest.xml. Without this, network calls can fail. Step 34. Clear text HTTP issue. During local development, you may call http:10.0.2.2 Android may block HTTP depending on configuration. Development only option. Application Android.uses clear text traffic true. Production best practice. Use HTTPS. Step 35. Permissions. Common permissions. Uses permission Android name, Android permission Internet. Uses permission Android name, Android permission camera. Uses permission Android name, Android permission access find location. Important. Some permissions need runtime permission request. Examples. Camera, location, microphone, notifications, storage, media. Step 36. Testing Android apps. Common tests. CUC. Unit tests, CUC. UI tests, CUC. Integration tests, CUC. Manual testing, CUC. Real device testing. Unit test example. Class login validator test. At test fun, valid email should return true. Val result equals is valid email, test at example.com. Assert true result. UI tests can test. Unclick form input. Unnavigation. Displayed text. Step 37. Build APK. Debug build. Gradle. Assemble, debug. Output. App, build, outputs, APK, debug. APK is useful for, local testing, sharing test builds, installing manually. Step 38. Build AAB. AAB means Android App Bundle. Used for Google Play. Command. .esc Gradle bundle release. Output. App, build, outputs, bundle, release. Step 39. Release preparation. Before release. Current app icon. Current app name. Current version code. Version name. Release signing. Privacy policy. Permissions review. Testing on real device. Crash monitoring. Play Store listing. Common release files. APK, AAB, key store, release notes. Important. Keep key store safe. Losing it can cause serious release problems. Step 40. Android deployment. Deployment options. Check. Install on emulator. Check. Install on physical device. Internal testing. Close testing. Open testing. Google Play production release. Typical flow. Build AAB. Upload to Google Play console. Internal testing. Close testing. Production release. Android project structure. For real apps. Recommended structure. App, CRC, main, Java, COM, example app, data, data API, local, model, repository, use case, UI, login, home, profile, settings, navigation. Welcome to MainActivity.kt. Benefits. Scalable, clean separation, easier testing, easier maintenance, better team collaboration. Android real-world example. Travel social app. Architecture. Android app. Spring Boot API. PostgreSQL. Image storage. Features. Color login. Color register. Profile. Create post. Upload image. View feed. Like posts. Comments. Location tagging. Android responsibilities. UI screens. Navigation. API calls, token handling, image picker, loading state, error handling. Backend responsibilities. Authentication, authorization, database operations, image upload, business logic, API security. Android plus Spring Boot system design. Architecture. Android mobile app. API gateway. Spring Boot services. PostgreSQL. Redis. Kafka RabbitMQ. Authentication. Login screen. Post API AUth login. JWT token. Token stored securely. Authorization header used. Media upload. Android selects image. Multi-part upload. Spring Boot stores image. Image URL returned. Android displays image. Common beginner mistakes. 1. Putting everything in MainActivity. Bad. UI, API calls, token storage, validation, and business logic inside MainActivity. Better. Screen means ViewModel, means repository, means API service 2. Using localhost from emulator. Bad. http://8080. Better. http://10.0.2.2.8080. Ignoring loading state. Bad. Bad. User taps button and screen does nothing. Better. Show loading spinner or disabled button. 4. Ignoring error state. Bad. API fails and user sees blank screen. Better. Show clear error message. 5. Logging sensitive data. Bad. Logd token. Better. Never log tokens, passwords, or private data. 6. Not testing on real device. Emulator is helpful, but real devices reveal keyboard issues, camera issues, network behavior, performance problems, notification issues. 7. Not using architecture. Bad. Everything mixed together. Better. UI plus ViewModel plus repository plus API layer. Android best practices. Check. Use Kotlin for new apps. Check. Learn Jetpack Compose. Understand XML for legacy apps. Check. Keep activity small. Check. Use ViewModel. Check. Use repository pattern. Check. Use Retrofit for APIs. Handle loading and error states. Use HTTPS in production. Avoid logging sensitive data. Do not hardcode secrets. Test on emulator and real device. Check. Organize project by features/layers. Check. Use meaningful models and DTOs. Check. Validate API responses. Check. Secure token storage. Use Gradle properly. Check. Prepare release signing carefully. Android interview questions. 1. What is Android? Android is a mobile operating system and platform used to run applications on phones, tablets, TVs, watches, and other devices. 2. What is Android Studio? Android Studio is the official IDE for Android app development. 3. What is an activity? An activity represents a screen or user interaction entry point in an Android app. 4. What is Jetpack Compose? Jetpack Compose is Android's modern UI toolkit for building native UI using Kotlin. XML layout is the traditional way to define Android UI using XML files. 6. What is ViewModel? ViewModel stores UI-related state and business logic and survives configuration changes. 7. What is Retrofit? Retrofit is a popular HTTP client library used to call REST APIs from Android apps. 8. What is Room? Room is Android's persistence library used to store local database data. 9. What is Gradle? Gradle is the build system used to compile, test, and package Android applications. 10. What is Logcat? Logcat is Android Studio's logging tool used to view app and system logs. 11. Why use 10.0.2.2? Android emulator uses 10.0.2.2 to access the host machine's localhost. 12. APK versus AAB. APK is Android package used to install apps. AAB is Android app bundle used for Google Play publishing. Android roadmap beginner level. Learn. Android Studio, Kotlin basics, MainActivity, Jetpack Compose, layouts, buttons, text fields, emulator, build, simple login screen, intermediate level, learned. Navigation, ViewModel, repository pattern, retrofit, JSON models, API integration, token handling. Build, Android Plus, Spring Boot login app, advanced level. Learn. Room database, offline support, work manager, push notifications, testing, release signing, Play Store deployment. Build, production-ready Android app, 30-day learning plan. Week 1, Android basics. Learn. Android Studio, Kotlin emulator, Kotlin basics, common MainActivity, compose text, button, text field. Practice. Build Hello Android and Login UI. Week 2, UI and Navigation. Learn. Column, row, a lazy column, state, navigation, multiple screens. Practice. Build login, home, and profile screens. Week 3, API integration. Learn. X retrofit, X models, X repository, X ViewModel, X loading state, X error handling, X Spring Boot API calls. Practice. Build Android app connected to backend API. Week 4, storage, debugging, release. Learn. Token storage, room basics, Logcat, debugger, permissions, APK AAB builds, testing. Practice. Build complete Android full stack mobile app, full stack project idea project, Android plus Spring Boot user management app. Features. Login, register, profile, user list, update profile, settings, JWT authentication, API error handling, loading state, logout. Architecture, Android app. Retrofit, Spring Boot REST API, PostgreSQL. Recommended Android packages. UI.login, UI.home, UI.profile, data.api data.model data.repository. Android development is a valuable skill for backend developers, full-stack developers, and mobile developers. Important concepts include Android Studio, Kotlin, Java Basics, MainActivity, Jetpack Compose, XML layouts, emulator, Gradle, activity lifecycle, ViewModel, repository pattern, retrofit, Android plus Spring Boot integration, token handling, local storage, Logcat, testing, APK AAB deployment. Backend developers already understand. Check. APIs, authentication, JSON, databases, business logic. This makes Android development easier to learn. Key idea. Android development allows backend developers to build complete mobile applications that connect to modern backend APIs.